So on the first 4 questions of this class opener, you need to know this fact. It doesn't matter what root you have, and it doesn't matter what kind of base you have in here. It could be a number, it could be a variable, and whatever power you have on it, that's what we call radical form. And what we're going to do is change that radical form. We're going to change it to exponential form. And it's this simple. The base is still going to be the base. You're going to have an exponent here, but it's going to be a fraction. Okay, so on the exponent position, we're going to put a fraction. And the power, this p right here, is simply going to be the numerator. So everybody should put the p on the numerator. And the root, this root right here, is going to be the denominator of that fraction that's on the exponent. So the rth root, right, whatever root it is, of whatever base to whatever power is going to be that same base to the power of power over root. Okay? So you're going to have a fraction as an exponent. The power goes up on top. The root goes on the bottom. If you know that, you should be able to do all of this on 1 through 4. So when we look at 1 through 4, we need to rewrite your rational exponent to a radical. Okay, so we all know, we should know, that this is saying the second root, so square root. And there is no power on the inside with the z. Okay, so we need to do the square root of z, and what the first problem that most students do is they write the whole thing inside the square root. But the only thing that has the 1/2 power is the z. So the only thing inside the square root should be the z, and that's it. What about that 21? The 21 doesn't have the power of 1/2, right? It would be a different story if I had parentheses like this indicating that the whole thing should be inside of the root. But we don't have parentheses, so we're not going to put the whole thing inside of the root. We're only going to put the z inside of the root, and we're going to keep the 21 out here. So there's your answer, 21 square root of z. Let's move on to number 2. The square root of 17 and x. We want to change that. This is not simplifying, right? You're not trying to break it down, rewrite it with multiplication. Right here, you're just trying to change it from a radical to an exponential power. Exponential form to radical, or radical to exponential form. So we need the whole thing 17 and x, we need that whole thing to the 1/2 power. So you put the 17x, obviously, inside parentheses. If you do not put the parentheses, it's going to be wrong on the test. So this is a section of the test that's too easy to mess up on. All you got to do is know how to rearrange it, how to rewrite it. Okay? You're not really doing any math. Tony, quit talking. Number 3. Right here, we want a root. So how do we do this? What was the relationship that we have?
Square root, and then you'll have x to the third on the inside and 5 on the outside, right?
What kind of root do we have? Fifth root. So we're going to put that 5 right there. And obviously the base is x, and the x is still going to be the base on the inside. And how about the power?
3.
The power is 3. So we're going to take that 3, put it right here as a power. Okay. By the way, just to let you know, this is a 100% correct answer, but this also is a 100% correct answer. Either one is fine. As long as you know that this top one is a power, it could be on the outside as a power, or it could even be on the inside as a power. It doesn't really make a difference. Okay, they're both correct. Let's move on to number 4. We want to change this to a power. So what am I going to write inside parentheses? So 7x to the 4th goes inside of the parentheses, and because this is the 5th root, I'm going to rewrite that as a 1/5 power, and we're just going to leave it like that as our final answer. Let's move on to simplifying problems. We are going to have lots of questions on the test that require simplification, and because your calculator could do simplification of roots that just have numbers, we're throwing variables in there. So there's going to be a lot of these with variables in there. So it doesn't matter how complicated it looks, what we're going to be doing is splitting up each root into each of the terms. So instead of 9 times a squared times d to the 4th, all underneath one root, I want to split up that root to each of them. I want to have the square root of 9 times the square root of a squared times the square root of d to the 4th. Now, the square root of 9, that's an easy problem. That's just 3. And when we think about what a square root is, it's really the 1/2 power. So we're really going to simply be dividing this exponent by 2. So that becomes a regular a. And the last one, the square root, is really the power of 1/2, which means we're going to divide the power of 4 by 2. So that becomes d to the second. Now, of course, if you wanted to be thorough showing your work, what you would do is this. You would rewrite the square root as the power of 1/2, and inside you'd have the d to the 4th, and then you would multiply the power to a power, giving you d to the 4 over 2, and 4 over 2 is really just 4 divided by 2, and that's how we get that answer over there of d squared. Anyway, this is your answer. There are no more square roots on it. It's just a simple answer, 3ad to the second. 3ad to the second. Let's move on. Okay, so this one was pretty easy. Why? Because we were doing the square root, and you could actually do the square root of that. You could divide this by 2 and divide that by 2. Not all of them are going to work out that easy. If we look at number 6, this is an example of one of those that doesn't work out that easy. So let's first split the root. So I've split the root, and that becomes 4 easier problems to deal with. And let's simplify each one of those. Now, the square root of 108. 108 is not a perfect square number, right? Since we're dealing with a square root here, we could think of our perfect square numbers, which are 4, 9, 16, 25, 36, 49, 64, 81, and so on, right? 100, 121. But anyway, the 108, it's not a perfect square number. It's not up there on that list. So I need to rewrite it with multiplication to get one of these numbers up on the list. So the question is, what will work? Will 16 times something give us 108? Will 36 times something give us 108? Will 49 times something give us 108? You're going to have calculators, so you could, 9 times 12 gives you 108. Okay, 9 is a perfect square number, but let's try a bigger perfect square number. How about 16? Could you do 108 divided by 16? It might work, right? 108 divided by 25 doesn't work. 108 divided by 36, what's that? That is 3. 106 divided by 36 is 3, which means that 108 divided by 36 is 3, which means that you could rewrite 108 as 36 times 3, and 36 is a perfect square number. So when you split it, you'll get the square root of 36, which is 6, and the square root of 3 just comes down. So that's barely this first part, the first question that we have right here. Let's do the second one. Now, a square root is really the power of 1/2. Which means that you want this power to be divisible by 2. And 5 is not divisible by 2. Okay?
X to the 4th times x to
Yes, we're going to rewrite it as x to the 4th times x to the 1. Again, if this is not divisible by 2 because it's a square root, it's a power of 1/2. If it's not divisible by 2, let's rewrite it with multiplication to get something that is divisible by 2, like the x to the 4th. That way, when you split it, you could actually do the square root of x to the 4th. You take that 4 and simply divide it by 2, and we will get x squared, no more root. Now, the other one, this guy right here, the square root of x, you're just going to leave it as the square root of x. Okay? And how about that square root of y to the 6th over here? That one's pretty easy. Because it is divisible by 2, it becomes y to the 3rd. Okay? Of course, I'm not showing my work. I hope you guys have already caught on that a square root is the power of 1/2, which means that you simply divide this by 2 and you get y to the 3rd. How about this last one? Z to the what? Z to the 2nd. Perfect. Okay. So this whole thing right here is our answer, but it is disgusting. It is out of order. It's not clean. Let's rearrange this to make it clean, make it nice. So I'm going to take all of my outside terms, the 6, the x squared, and the y to the 3rd, and the z to the 2nd. I'm going to write that all together. 6 x squared, y to the 3rd, and z to the 2nd. And then we put our square root of 3 and our square root of x together underneath one square root. So I'm going to put 3 and x together underneath one square root. And ladies and gentlemen, this is our answer right here in red, in the red box. 6x squared, y to the 3rd, z to the 2nd, square root of 3x. All right, so let's jump to the next one, number 7. This is a cube root this time, a cube root. So you might want to think of your perfect cubed numbers, right? So if I think of my first perfect cube number as 1, that doesn't really help us. But the next perfect cube number, when I go 2 times 2 times 2, what do I get? 8. That's a perfect cube number. What's the next one? 3 times 3 times 3? 27. How about 4 times 4 times 4? 64. How about 125? 5 times 5 times 5. And you know what? We could stop right there because 108 it's less than 125. So the question is, could I find a number that I multiply with itself 3 times to give me 108? And the answer is no, right? Because 108 is not up here. So could I use one of these perfect cube numbers to rewrite it with multiplication to get 108? So like, will 8 times something give me 108? Will 27 times something give me 108? Or 64 times something give me 108?
27 times what? 36 and 3.
Okay, but 36 is not up here. 36 is not up here. 27 times what? 4. Now, if you have a calculator, the way to do this would be to simply take 108 and try to divide it by 8. Take 108, try to divide it by 27. Take 108, try to divide it by... And there's only 3 numbers, really. Right? And when you do it, you'll see that 27 works. When you do 28 divided, or 108 divided by 27, what do we get? 4? So that'll be 27 times 4. You know what? I should show all my work. The first part is to split it. I'm sorry. The first part is to split it. Okay, now we said that 27 times 4 is 108. That way when you split the third root onto each of those, you'll be able to do the cube root of 27, which is what? 3. And then the cube root of 4 stays. And now we need to do this guy over here, the cube root of x to the 4th. So the cube root is kind of like taking that exponent and dividing it by 3. So you want something divisible by 3. 4 is not divisible by 3. So you're going to rewrite it with multiplication. So you're going to change it to x to the 3rd times x to the 1. That way when you split that third root to each of those, you'll be able to do this first one right here. The cube root of x to the 3rd, that's just x. And then the cube root of x to the 1, you're just going to rewrite it, the cube root of x to the 1. So this is our nasty looking answer. We need to rearrange it in order. So what's my final answer going to be? 3x cube root of 4x. There's your final answer right there for number 7. Okay? Practice makes perfect, guys.
I understand now.
Here's one kind of a review question. We have to use that key concept that you're able to split the root. So the very first thing to do on number 8 would be to split the root to the q and split the root to the 20. And then what? Could you simplify anything?
The 20.
Yeah, the square root of 20, you could actually simplify it. 4 times 5, right? So 20 is not a perfect square number. Let me rewrite it right here, the square root of 20. Square root of 20 is not a perfect square number, so you want to rewrite it with multiplication to get a perfect square number. So you're not going to use 2 and 10, you're going to use 4 times 5 because 4 is a perfect square number. So you're going to have 2 square root of 5. So check this out, guys. The square root of 20 is really 2 square root of 5. So I'm going to rewrite the square root of 20 on the bottom. I'm going to rewrite it as 2 square root of 5. So my new problem is the square root of q up on top over 2 square root of 5 on the bottom.
And then you have to multiply it times 2 square root of 5.
And we need to get rid of the square root of 5 on the bottom. Like, we don't really have a problem with the 2. We don't care about the 2. We just don't want this square root. So we're going to multiply both top and bottom by that same square root of 5 value. Okay? Now, when I multiply the radical q times the radical 5, the square root of q times the square root of 5, you could simply put those together underneath one radical. You're not going to write q5, you're going to write 5q. That's right. And on the bottom, we know that the square root of 5 and square root of 5 becomes what? Just 5. So we have the 2 that was out there, and we have this guy and this guy, which become one single 5, no more square root. So our final answer to number 8 will be the square root of 5q over 10. The square root of 5q over 10. That's number 8. All of these questions are on the test that we're taking on Tuesday, all right? or very similar to them. Number 9. What do we do first? Split it up. Oh yeah, by the way, this negative 3, it's not really negative 3 to the third, it's just negative 3 times. So let's just ignore this negative 3 for a little while. Let's split up this cube root to each one of those. So we're going to have the cube root of 162, the cube root of x to the 9th, and the cube root of y to the 4th. So we need a perfect cube number. We might need to make a perfect cube list once again to help us out. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. And we're already too big. You don't have to go any further because 62 is very close to 125. Anyway, which one of these perfect cube numbers will work when I divide 162 by it? So on a calculator, all you have to do is say 162 and try to divide it by, let's say, 27. And if I do divide 162 by one of these perfect square numbers like 27, I'll get the answer 6, which means that 27 times 6 is 162. So 27 times 6 is 162. That way we could split the cube root now, and we'll be able to do the cube root of 27, which is 3, and the cube root of 6 is going to stay. Now over here, the cube root is really the 1/3 power, which means I'm technically going to just divide this 9 by 3. So that becomes what? X to the 3rd. And this last one, I know that the cube root is really the 1/3 power, so I want this to be divisible by 3. But since it's not divisible by 3, I'm going to rewrite it with multiplication. I'm going to rewrite it as y to the 3rd times y. That way when I split the cube root, I'll be able to do the first one, y to the 3rd, or the cube root of y to the 3rd, which is just y. But then again, I'll have the cube root of y left over. So all of that is our answer. We just need to rearrange it. So let's put our answer together. 3x to the 3rd y. And we're going to put the cube roots together, right? We got the 3x to the 3rd y. Now let's put this cube root and that cube root together. So we have the cube root of 6 and y together. So that seems like our answer, but it's still not our final answer because I forgot that there's this negative 3 that I need to multiply by out on the outside. So we need to bring that down, multiply it by negative 3. So our final answer, number 9, would be negative 3 times 3. That's negative 9 x to the 3rd y, cube root of 6y. That's it. Last question. Number 10. Let's split it up. So splitting it up, you have the 6th root on all those. So we need to think of a number that you multiply with itself that'll give you 128. It might work, it might not work. Let's try it. Now, with itself 6 times, let's start with the first number 2. If I go 2 times 2, I get 4. Times 2, I get 8. Times 2, I get 16. Times 2, I get 32. Times 2, I get 64. So that gives me 64, right? And right there I do have 1, 2, 3, 4, 5, 6 2's. So I have 2 to the 6th power is 64. Now, I wanted it to give me this, but it gave me 64. But notice that 64 times 1 more 2 will be 128. So what I'm going to do is I'm going to rewrite 128 as 64 times 2. Now, why do I want this 64 there? Because I could actually do the 6th root of 64. I can't do the 6th root of 2, but I could do the 6th root of 64. That's just the number 2. Okay? And then the 6th root of 2 just simply comes down. Let's move on to the next one. Again, the 6th root is kind of like dividing this power by 6. So what's the answer there going to be? X to the 3rd. 18 divided by 6 is 3. And over here, the 6th root is kind of like dividing by 6. In other words, I want this 17 to be divisible by 6. Right? So what is a number divisible by 6? Is 17 divisible by 6? How about 16? How about 15? How about 14? How about 13? How about 12? Yes, 12. So I need to rewrite this as y to the 12th times y to the 5th, because 12 plus 5 is 17. Does that make sense? Okay, so I rewrote it as y to the 12th because now that y to the 12th is divisible by 6. So what is the 6th root of y to the 12th? Y to the 2nd. So you really have y to the 2nd power. And the 6th root of y to the 5th you can't do, so you just rewrite it. So all of this is our answer. We just need to rearrange it. So let's put the outside terms, the 2, the x to the 3rd, the y to the 2nd, put them all together. So we have 2x to the 3rd, y to the 2nd, and then we're going to put the radicals together. We have the 6th root of 2 and the 6th root of y to the 5th. Let's put them together underneath 1/6 root. So that would be 2y to the 5th. That is your final answer for number 10. Guys, this class opener is kind of like a review for the test next week. All right, watch this class opener over and over again. It'll help you out, help you perform better on the simplifying part of next week's test.